Okay, I'm Dario, and today we're gonna do the integrative activity. So, first of all, KMnO4 is inorganic and benzene is organic. Okay, we're gonna start with benzene. This one is organic because it has carbon and hydrogens. So, first of all, boiling point 80, because it is less than 100, it means it is organic because it is below 100, and that is a property of organic compounds. Then, evaporates easily. It is also a characteristic of organic compounds, therefore it relates to benzene again. And last of all, soluble in non-polar covalent solvent, sorry. It is also organic. It is also an organic property, so that therefore it goes with benzene. Then KMnO4, the rest of them obviously goes to KMnO4. We're going to highlight them. So soluble in water is an inorganic property, therefore it is KMnO4. Not flammable, it is inorganic because only organic compounds are flammable. Melting point of 240, that is very high, therefore it is an inorganic because inorganic it is a property. And this one is more dense than water, therefore it is inorganic because that is an inorganic property. And last of all, poor electrical conductivity, that is an inorganic property, therefore it is inorganic and it relates to KMnO4. That is it. Let's go to our next one. Okay, next one. Solubility in water. Slightly soluble, it means it's poorly soluble. That is an organic property. Then flammability, yes, by that we can say it is organic, unlike inorganic that it is not flammable. Electrical conductivity in water, that is an organic property also. And here we can see that it is less dense than water, which means it is organic, because inorganic is more dense than water. So we can therefore say that substance X is organic. Okay, then for our last question, we can see what hybridizing is present in carbon 2. Okay, first we identify carbon 2 and we can see that it has 3 bonds and 1 in the other side. By that reason, we know that it is an sp, because sp has that kind of bonds. Then, how many pure orbitals are present in carbon 3? We can identify carbon 3 and we know it is this one. Let's see. There is 2 bonds in one side and 1 bond in the other side. We can see that it is sp2, and sp2 has only 1 pure orbital according to the table our teacher gave us. That's how we can identify how many pure orbitals it has, by identifying its characteristic, which is sp2. I repeat, sp2. Then, total of sp2 carbons in the whole molecule. Okay, we can identify, here is 1, 2, 3, 4, 5, and 6. We can know that because sp2 carbons has 2 bonds at least on one side. Here we can see 1, 2, 1, 2, 1, 2, and 1, 2. This one is an exception because it has 2 on both sides, so it doesn't count. That is how I was able to identify the sp2 carbons in this molecule. Then, for our last question, what carbons do not follow tetravalence rules? We can see that this one and this one. Why? Because it has, if we count the total of bonds, 1, 2, 3 lines, 4 lines plus an H, which means it has a total of 5 bonds. So it does not follow tetravalence rules. And also this one. Number 3, because as if we count them, 1, 2, 3, and it has 2H. 2H adds another 2 more bonds, which is a total of 5. So these ones are the only two that do not follow S tetravalence rules. And I forgot to answer this one. This has 6. 1, 2, 3, 4, 5, and 6. And that is it. Thank you very much. Goodbye.